All right, we are here to talk a little bit about concavity, and I'm going to talk about inflection points, all of this together. I'm only going to do one. It's going to take us a long time. I'm only going to do one, but I'm going to talk about everything. So even though I'm not going to do the other ones, you should be ready to try on your own. And this is one of those days where you're probably going to need, you can use the whiteboard. You're going to need probably both sides of the whiteboard, okay? A lot of work to do. Okay, so we have a function f of x. And this question is saying to find x values where the function has inflection points. Now, the way you're going to do this is you're going to first figure out the concavity, the intervals on which this function is concave up and concave down. Because where your function changes from concave up to concave down or vice versa, that is called an inflection point. All right, so all the work is going to be the same, just the conclusions at the end will be a little bit different. Okay? So the way I'm going to do this, because I care about seeing where my derivative is increasing or decreasing, I'm going to need to go to the second derivative here. Okay? So what did they give me? The original function. So let's take the first derivative. I'm telling you that because concavity is looking at where the derivative values are increasing or decreasing, I need to go past that, Georgie, to get the second derivative. Okay? So what is the derivative of 1/6 x to the fourth power? I'm going to reduce it, but yes, it is 4/6 or 2/3 x cubed. The derivative of x cubed? 3x squared. Remember, you're writing small, all right? Minus 20x. Again, am I stopping here? No, I need to go to the second derivative. Okay, second derivative. Okay, what's the derivative of 2/3 x cubed? Squared plus 6x minus 20. All right, so hopefully you notice, I know we're doing another derivative, but nothing's really new here, just taking derivatives. I want to find critical points, right? Critical points, this is where your function, in this case, your derivative or second derivative is equal to 0 or undefined. Again, this is a polynomial, so don't have to worry about undefined, but that's where the interesting stuff could happen. So set it equal to 0. Can I factor anything out? 2, let's take out the 2. X squared plus 3x minus 10. Okay, remember you're writing small? What a great song. One of my favorite Liverpool chants. Okay, factors of negative 10. I'll sing it later, don't worry about it. Factors of negative 10 that add to 3. Let's see, positive 5 and negative 2, that's negative 10. Okay, that looks good. What makes each of those 0? Okay, and do I care about this 2 that we factored out? No, why not? Because it doesn't have an x, but if it did, I'd throw a 0 in there for another critical point. Okay, everyone all right? This is the same stuff, nothing new right now. Okay, so I'm going to make my number line. You guys ready to make the number line? So make the number line. Try your best to organize it, right, to help your brain know what you're doing. I've got negative 5. I've got positive 2. All right, remember, the idea is I care about what's happening between negative infinity and negative 5, negative 5 and positive 2, and then 2 to positive infinity. That's where some interesting stuff could be happening. Okay? Let's do our test points. What test point am I going to use first? I'm going to use negative 6. What about in between negative 5 and positive 2? I'm going to use 0. You can totally use 1. Totally use 1. Use 1 if you want. I'm going to use 0. Okay? And then to the right of 2, I'm going to use 3. But you could use anything you wanted to the right of 2. Okay? All right. Now, when you're writing down what's happening here, make sure you're writing down this is the sign of the second derivative, right? The sign of the second derivative. So here we go. Plugging in negative 6. Again, do I care about the 2? No. If it had been a negative 2, I'd care. But because it's a positive 2, it doesn't really matter. So what's negative 6 plus 5? It's a negative value. Negative 6 minus 2. Another negative. A negative times a negative. Positive. Okay, let's plug in 0, or if you plugged in 1, you get the same thing. Jimena. 0 plus 5, positive. 0 minus 2, negative. Positive times a negative. Negative. And last but not least, if I plug in that 3 or anything to the right of that positive 2, you should see everything is positive. Now, up until this moment, you would say, based on this, that because you see positives here, that would be where the derivative is increasing, right? Remember, that's what we're trying to say, that you can go 1 above what you did. This is the second derivative. So if I back up 1 to the first derivative, I'm saying the first derivative is increasing on these two intervals, negative infinity to negative 5 and 2 to infinity. I'm saying the derivative is decreasing on this interval, negative 5 to 2. Hopefully, you know, we've kind of already done that. All right, so today, the difference is, instead of saying that the derivative is increasing or decreasing, we're going to say the original function is concave up, which is where the derivative is increasing, on negative infinity to negative 5, or from 2 to infinity. The function is concave down for the only other one, which is negative 5 to positive 2. I'm going to pause here. I'm not done, but I'm just going to pause. So what I'm hoping your brain is seeing is that your second derivative sign can make conclusions about the original function now. And those conclusions are about concavity. Everyone okay? Okay, now this question doesn't say, where is it concave down? Where is it concave up? That's what I just wrote. It says, where are the inflection points? So this is where you want to write down the x values where you're changing your concavity. So it's changing from either concave up to concave down, or concave down to concave up. Now in this one, right, we're starting with concave up, and then we change to what? Concave down. So you go back up. What's the critical point at which this is happening? Negative 5. So one of my answers here is going to be negative 5, because we're changing from concave up to concave down at negative 5. Don't worry, I'm going to show you graphically. All right, I'll try to help your brain. Okay, so we're concave up until negative 5. Then we switch to concave down until positive 2. What happens after positive 2? We switch to concave up. So I have to go back up here and look. What's another answer for this question? Positive 2. Now, I know you're thinking, Gael, you always ask these questions. They're great questions. Gael's probably thinking, will my critical points from my second derivative always be my inflection points? No, right? The idea is, I know that both of these became the answer, but is there a chance that maybe only one of them is the answer, or none of them are the answer? All right? Yes. This will be where the answers will come from. They'll come from these critical points, but I'm not guaranteeing that they'll always be inflection points. Okay? You'll definitely have questions where they both don't work. Can I guys show you the graph? Can I show you the graph? Okay. Go ahead. He said positive, negative, negative. So positive, negative, negative. The only one would be negative 5. If it was negative, negative, positive, the only one would be positive 2. Yeah, it's got to be where it changes concavity.
So inflection is where it changes.
Correct. Always inflection points is where it changes concavity.
What's the other one that they were asking?
Either, let's say, where is it concave up or concave down? All right, ready? All right, let's graph it. Was it 1/6 to start? X to the 4th power? Okay, keep going. Plus x cubed. Thank you. And I'm going to try to put in all the stuff that we ended up caring about. We had, was it negative 5 was one of our critical points? So I did negative 6, right? Then negative 5, then I did 0, then I had 2, and I did 3. Awesome. Thank you, guys. Okay, ready? Okay, I'm going to do my best here. If your brain doesn't get this right away, it's okay. I promise it's going to take some time. It took me many, many years. Okay, here we go. Ready? Okay. So first off, the thing in, let me do this. The thing in red, that curve in red, is the original function. Okay? Because everyone has that in their brain. That's the original function. What is happening as I move to the right? This right here is decreasing. Does everyone see decreasing? Right? Then where does it switch to increasing? Probably at around -8 is where we're now increasing. Then it switches back to decreasing at 0, and then probably around just shy of 4, switches back to increasing all the way. I didn't ask you about that, right? I asked you about concavity. Where is it concave up? Where is it concave down? So watch this. The way you want to think about this is concavity is all about where is the derivative increasing or decreasing. So my brain, this works for me, is I take like infinite tangent lines, right? So if I take a tangent line right here, how would you describe the slope of that tangent line right there? How would you just say like a number? Negative, that's the key one. Negative, pretty steep, right? -9, like it's very steep. How would you say here? Negative, but less steep. So what's happening to my tangent lines as I move this way? They're getting, I know it's going to be weird to say, they're actually getting larger. They're getting less negatively steep. You see that, Kyle? So this is concave up. Where did we say we're changing? I know. Where are we saying that we're changing? Let me try this. Right, so -9, -5, I don't know, -3. Look at this one here. How would you describe that slope? 0. But then what about these? They're getting more and more positive, right? So we're still, even, it's weird because like you're changing, increasing, decreasing, but you're still the same concavity. I know, it's your brain takes a while. Where do we change to concave down? -5, right here. So right here, we stop having our tangent lines increasing. Now if you look at the slopes of these tangent lines, they're getting smaller, right? It's getting closer to 0. And then here we have negative. Where do we change back to the slopes are increasing? Actually, it was at 2, right? Wasn't it at 2? Yeah, it was at 2, right? So now they're getting a little bit, right, getting closer to 0 and then getting positive. This is tough, guys, okay? So that's why the answers were -5 and 2.
Wait, so what's the slope at?
Hold on, David, I think said was on the first I'm gonna come to you. Go ahead.
Can't you just like if you have the point right there, like where the slope is 0, and then you find where the other slope is 0, can't you just do the exact middle to find the inflection point?
That's not the
Since
middle though.
it's like right there on 0, the tangent line, it's 0, right?
I think you're trying to do something with like finding like the midpoint of something or the average or the median. I wouldn't do any of that.
Wait, I don't understand
It
what
doesn't
that
make
is.
that work.
Again, looks like it kind of works. It's different from it works. Yeah, Georgie.
What's the slope at -5 and 2?
Ah, great question. What is this slope here? You would have to find. Do you really want to know?
Oh, but I thought it was just 1. It was like
Let's see. I know whatever the answer is going to be before it, like right before -5 and right after -5. The difference is because we're changing from the slopes have been increasing to now they're decreasing. We're going to get smaller as we move to the right of -5. That's what I can tell you for sure. Let me try this. Will it like this? I don't know if it'll like this. Let's see if it likes this. Nope, let's do this. You want to know what the slope was at -5, right? That's what you said, right?
Yeah.
Okay. It is 92 is the y value? That doesn't make sense.
So then if you do -4, it would be
It should technically, I'm sure I did something wrong. I was trying to do it really fast here. Well, it should be less, so maybe it is less. But anyway. Okay.
Oh, like it stops going up and it starts going like that.
Well, I don't want to say up. I want to say it stops, the slopes